Okay, ma'am. So lambda is equal to h by p is equal to h by mv. We started with this. We substituted p is equal to mv, and momentum and kinetic energy of any material particle of mass m and kinetic energy k are related by p is equal to root of 2m into k. Then from that we'll get the formula lambda is equal to h by root of 2m into k. Then next we said a charged particle q accelerated by voltage v will gain a kinetic energy k is equal to qv. Can you tell me proton gains kinetic energy and moves in the direction of electric field or opposite to electric field?
Proton will move in opposite of electric field only, sir.
Proton will move in the direction of opposite of electric field, huh?
Yes, sir.
Are you sure?
Yes, sir.
This is positive plate. This is negative plate, correct?
Yes, sir.
And the direction of electric field is always taken from positive to negative plate, correct? Yes or no?
Sir.
Direction of electric field is always taken from positive to negative plate. Correct only? Electric field direction.
Hello, sir.
Electric field direction.
Yes, sir.
Will be away from positive plate and towards negative plate.
Yes, sir.
Now proton in what direction it moves?
Towards negative plate, sir. Away from positive plate, sir.
Means in the direction of electric field and opposite to electric field.
Sir, from positive to negative means electric field will move away, sir. Negative to positive means towards negative it will move, sir.
No, you are not getting my question. Direction of electric field is from positive plate to negative plate. That is number one.
Yes, sir.
Proton will move away from positive plate.
Yes, sir.
Now my question is, in what direction proton moves? Along the field, opposite to field?
Opposite to the field, sir.
No. Opposite to field means proton should move like this. How it moves?
Yes, sir. Yes, sir.
Yeah, I think you're not alert.
Yes, sir.
Yeah, I'll keep class at 5 o'clock, right?
No, sir. Some voice only hearing, sir. Sometimes voice not hearing, sir.
Okay. No, are you able to clear now?
Some only hearing, sir. Voice in between not coming.
Network problem, right? Here we have got excellent network.
Yes, sir.
Yeah, I think some problem with the net is there with you. Now remember.
Tower, I think. I think tower issues, sir.
Yeah, some problem with the network there only.
Yes, sir.
Okay. So once again, I am repeating. Listen here carefully. Electric field direction is from positive plate to negative plate. Correct?
Yes, sir.
Proton moves away from the field, means away from the positive plate. Therefore, proton moves in the direction of electric field. Fundamental point.
Yes, sir.
Electron moves opposite to electric field. Got it?
Yes, sir.
So the kinetic energy gained by any charged particle under the potential difference of V volts is K is equal to Q into V. Therefore, the formula for de Broglie wavelength will become lambda is equal to H by root of 2m into QV.
Yes, sir.
Then I substituted the values of charge and mass of the electron, and finally I got the value of de Broglie wavelength of electron as lambda is equal to 12.27 by root V angstrom units. Correct?
Yes, sir.
Now you are able to hear clearly?
Yes, sir.
Okay, ma'am. So then, from that formula, what can you write? Lambda varies inversely as square root of potential difference.
Yes,
Therefore,
sir.
lambda 1 by lambda,
By lambda 2 is equals to root over V2 by V1.
Simple. Yesterday, I think I even told you, proton is
Yes.
there, alpha particle is there. Let us say like this. We have proton, neutron, alpha particle. So, the mass of proton, mh, the mass of neutron, mh. Proton means you can show with hydrogen. Neutron means deuterium. Alpha particle means helium, correct?
Helium. Yes, sir.
So, mass of proton is mh, mass of neutron is 2mh, mass of alpha particle is 4mh. Correct? Huh?
Yes, sir.
What are the charges? E plus E on the proton,
Yes, sir.
plus E
Two.
on the neutron.
Yes, sir. Helium 4 times.
Alpha particle how much?
2E, sir.
Good, 2E. So, lambda varies. Yesterday we said root of 1 by root of m into
M
Q.
Q.
Correct? Huh?
Yes, sir.
For same voltage. Yes or no?
Yes, sir.
So, lambda proton is to lambda neutron is to
It's
lambda.
lambda helium.
Yeah, it came in exams. So, you have to remember this. Try this
Yes.
3 times or 4 times and try to memorize. Okay?
Yes, sir.
So, that helps you to save your time. Yes.
Yes,
1 by mass of proton, mh, charge on the proton, E, is to 1 by
One.
half
Root over M 2mh into E
is to 1 by
into 4 1 by root of 4.
2 into 4mh into 2e, correct?
Yes, sir.
So this mhe can be cancelled in all.
Yes, sir.
Okay?
Yes, sir.
mhe can be cancelled and we get, so this is, yeah, 2 2s are 4, means 4 is 2.
Sir, 1 second, sir. Here, how, sir? 2 into 4h, 4mh into 2e.
Mass of alpha particle is 4mh, na?
4 times only, sir. Then here again 2 we are mentioning, no, sir.
So it is m into q, na?
Yes, sir.
Achha, we need not put 2 here, correct? Yeah, you're right. So how much it is? It is 8 means 2 root 2, correct?
Yes, sir.
So 2 root 2 is 2. Here how much you will get? It is
Fully cancel.
means
2 root 2.
2 root 2 is to 2 is to 1. Please check.
mh into E. mh.
2 root 2 is to 2 is to 1.
Yes, sir.
Correct?
Sir, here it is 2 only, root 2 only will come now, sir.
Yeah, for neutron, for proton mh ma. For neutron 2mh,
Yes,
for
sir.
alpha particle 4mh.
That means here root 2 only will come now, sir.
No, this root 2 and root 2 will cancel, na? See,
Yes, sir.
correct only?
Yes, sir.
So, is this formula, is this value correct? 2 root 2 is to 2 is to 1.
Yes, sir.
Yeah, correct. It's correct only.
Yes, sir.
Next, for this formula, suppose V1 is equal to 100 volts.
Yes.
V2 is equal to some 400 volts. Then,
Yes.
what is the ratio of these wavelengths? Lambda 1 is to lambda 2 is root of 400 by 100 means what is the answer?
2 is to 1, sir.
Simple. These models are simple only, but very important from a NEET point of view. Okay?
Yes, sir.
Yes. One more important concept is there. After covering, we will try to do few more models. Yesterday, of course, I made a reference of it. We said according to the kinetic theory of gases, there is a law called
Law of equipartition.
equipartition
Yes.
of energy.
Yes, sir.
So what it states, the total energy of any material particle available will be distributed equally
Equally amount.
possible modes of motion. So for any particle that according to the law of equipartition of energy, it is 3/2 kb into T.
Yes, sir.
kb is nothing but Boltzmann constant. We call it as Boltzmann constant.
Boltzmann.
So
Yes.
let us pick out that equation. Formula for wavelength lambda is equal to h by root of 2m into k. That is h by root of 2m into 3/2 kBT. So for any material particle, this kb Boltzmann constant, it is universal constant by, I think, Avogadro number. Please check.
Yes, sir.
Am I right, ma?
Yes, sir.
The formula for Boltzmann constant is universal gas constant by Avogadro number. So it is
6.023 into 10 to the power of 20.
yeah, correct. So universal gas constant is how much? What is the value of universal gas constant? 2 calories.
Or 8.314.
Yes, 8.314 joules mole inverse Kelvin inverse, correct?
Yes, sir.
By 6.023 into 10 to the power of 23. So
Yes,
this
sir.
comes out to be around 1.4. Yeah, nearly 1.3 something. 1.3 something into 10 to the power of minus 23. This is the value of Boltzmann constant. So this is a universal gas constant, universal constant. Capital R is universally constant. Even Boltzmann also is universally constant. Therefore,
Yes.
lambda varies directly as under root of m into t. Correct?
Yes, sir.
Because kb is constant. From this, what formula you can write? Lambda 1 by lambda 2
Lambda 2
is
equal
equal to m2 by m1 into t2 by t1. Correct,
Yes,
ma?
sir. Yes, sir.
No problem in understanding it, na?
No, sir.
Okay. Then, so what is the formula here? If you cancel this t, the formula
M,
wavelength
M,
is h
3m root h, lambda into h by 3m kbt into t, sir.
m kb into t. Correct. Because sometimes they may ask even formula. Yes or
Yes,
no?
sir.
So you should
Yes,
be remembering the formula also, not only the ratios.
Yes,
The main formula also you should be remembering.
yes, sir.
Okay. So these are all the important things. And one more conceptual thing is there that also will do it. And after that,
Yes,
we'll select some problems.
Yes, sir.
Now, the very important formula for wavelength is lambda is equal to h by mv. So, what are the implications from this? Two possibilities are there. If v is equal to infinity,
Yes, sir.
not possible. Velocity can never become infinity. But let us assume. Second one is v is equal to 0. Correct?
Yes, sir.
Then, if I substitute v is equal to infinity, what is your answer?
H by m into infinity.
Means
Anything by infinity is 0.
So what is the wavelength of that material particle?
Wavelength will be 0, sir.
No wavelength.
Yes, sir. Lambda 0.
Lambda 0. I wrote here. Could you see that?
Now, yes, sir.
Are you able to see the screen?
Yes, sir.
Okay. Now coming to this. Substitute V is equal to 0.
Yes, sir.
Then what is lambda?
Lambda is equals to h by m into infinity, sir. That means lambda m into 0, sir.
M into
So
0.
anything 1 by 0 is equals to infinity. So lambda will be infinity, sir.
Infinity. So now there is no problem with this. Lambda infinity means no issue. But lambda 0 means how do you locate the particle? The problem comes in the location of the particle.
Yes,
So in
sir.
either case, what de Broglie suggested is this is how we assumed a matter wave
Yes, sir.
of a material particle. You can find this a graph in what I mean NCERT textbook.
Yes, sir.
Uncertainty. I referred about Heisenberg's uncertainty principle is there. I think you might have
Yes,
learned.
sir. Momentum and mass cannot be located.
It is very they cannot be certain at one instant of time.
Yes, sir.
So uncertainty is the essential feature in the location of the particle. And here, this is the wavelength, correct?
Yes, sir.
The distance in the region, the distance between the 2 points in the region where the particles are in the same state of vibration. So this can be the wavelength. Means the particle can be located anywhere in this, correct?
Yes, sir.
So this particular graph will help you to locate the material particle, and this can be also considering as a conceptual question. So just note down the point, ma, please. I'll dictate. Please note
Yes,
it down. Take this first.
sir. Written, sir.
Okay. And one more important point. Wavelength of material particle, will it depend on charge or independent of charge?
Wavelength will depend on charge, sir.
Show me where is the charge in that formula.
Sir, we written no, sir. Lambda is equals to
No, this is the main formula. What is the main formula here?
h by mv, sir.
What is the basic formula given by de Broglie? Lambda is equal to h by mv.
H by p, sir.
H by mv, correct?
Yes, sir.
Those in place of mv we put root of 2mk. In place of k we put vq and all. That are all deduced relations.
Yes, sir.
This is the main formula.
Yes, sir.
Does it contain charge?
No, sir.
Therefore,
Therefore, it is independent of charge.
simple. Please write these points.
Yes, sir.
Number 1. For the matter wave of very large high intensity, for the matter wave of
Yes, sir.
very high intensity in a given region,
Yes, sir.
there is a greater probability. I am referring about this probability curve.
Yes, sir.
There is a greater probability of the particle
Yes, sir.
where the intensity is small. Where the intensity is small.
Yes, sir.
Since smaller the intensity means energy mass. Since smaller the energy,
yes, sir.
lesser will be the speed.
Yes, sir.
Hence can be located easily. Correct?
Yes, sir. Written.
I'll just give you a simple example. Suppose you're standing on the platform.
Yes, sir.
Railway platform. Tejas Express is running between, say, Chennai and Kanyakumari. Let us assume.
Yes, sir.
You know the speed of Tejas Express, ma?
Sir?
Tejas Express speed, you know?
No, sir.
It is 250 kilometers per hour.
Yes, sir.
Yeah, normal trains, they move an average speed of 60 to 80 kilometers per hour.
Yes, sir.
Tejas Express will move with the speed of 250 kilometers per hour.
Yes, sir.
We are having Tejas Express from Bombay to Ahmedabad and Delhi to Agra, etc. Selected routes. They are
Yes,
running
sir.
now. So if you stand on the platform and observe the Tejas Express, it's like jib jab zoo. Means you can't see anything. You don't know when it approaches and leaves.
Yes, sir.
Why? Because its speed is very high.
Yes, sir.
It will be very difficult for us to locate it.
Yes, sir.
Whereas for a passenger train, even you can usually peep into the windows and see who are sitting in the compartment.
Yes, sir.
Just for physical example, I am giving to make you understand why the location of the particle becomes easier with lesser energy means speed will be less. When speed is less, energy is less. When energy is less, intensity is less. Means chances of location of particle in that region are more.
Yes, sir.
That is the meaning of this statement. Okay.
Yes, sir.
Next, second point.
Yes.
Since
Since
the position of the wave cannot be located, exactly, hence wave nature of material particle,
wave nature of
material particle
yes, sir.
results in the uncertainty in the location of the particle. The uncertainty in the location of the particle.
Yes, sir.
Next point. Third point.
Yes, sir.
The particle location.
Yes, sir.
In the region of uncertainty.
Yes, sir.
Will be known using the wavelength. So I'm just explaining this. I'm giving you this point.
Yes, sir.
Will be given by the wavelength.
Yes, sir.
That is the
Yes,
distance through which the wave extends. The distance through which a wave extends, single wave extends,
yes, sir.
will help us in locating the particle. Last point. Last but one point.
Yes, sir.
The de Broglie wavelength is independent of the de Broglie wavelength is independent of
yes, sir.
the charge on the particle.
Yes, sir.
For example, proton has de Broglie wavelength, electron has de Broglie wavelength, positron has de Broglie wavelength. All these particles have got charge, correct?
Yes, sir.
Next, photon has got de Broglie wavelength.
Yes, sir.
Electromagnetic, no charge.
Yes, sir.
Neutron electrically neutral particle. It has mass, has some speed when it is free out of the nucleus, but it has no charge.
Yes, sir.
But they have wavelength.
Yes, sir.
That is the meaning of this statement. Understood that?
Yes, sir.
Okay, ma'am. I think this don't need any explanation. Nah?
Yes, sir.
Yeah, you can draw this. Have you drawn this diagram? De Broglie wave.
Yes, sir. Down, sir.
Yeah, put the heading De Broglie wave.
Yes, sir.
Okay, these are all one last point you just mentioned.
Yes, sir.
I'm not explaining the experiment. You are
Yes,
interested.
yes, sir.
Davison and Germer.
And German experiment.
Davison and Germer.
Yes.
What they did, ma?
Sir.
Have you heard these names?
Yes, sir. Davison and German. Last paragraph in NCR.
Davison and Germer
Yes, sir.
verified the dual nature for an electron. Dual nature for the electron.
Dual nature of electron.
Dual nature of electron experimentally.
Yes, sir.
Under operating voltages of.
Sir.
Under operating voltages of.
Under operating voltages of
44 volts to 68 volts.
68 volts. Yes.
Volts. For operating voltage of 54 volts, you need not remember these values, only for idea I'm just giving.
Yes, sir.
Voltage of 54 volts,
Yes, sir.
the electron was found to scatter
Yes, sir.
through 50 degrees.
The 54 volts.
Through 50 degrees.
It was scattered.
Yeah, these numbers you did not remember, but the last point you remember. The measured wavelength of matter waves of electron. The measured wavelength of
matter waves of
electron.
Yes, sir.
The measured wavelength of matter waves of electron using the diffraction technique.
Using the diffraction technique. Yes, sir.
Is 0.165 nanometers. 0.165 nanometers.
Yes, sir.
Some books will have 166 also.
Yes, sir.
So remember 0.165 or 166 doesn't make much difference because nanometers will be in the order of 10 to the power of -9. So that doesn't make much difference.
Yes, sir.
Okay.
Yes, sir.
Use. Application.
Yes.
The wave properties of electrons. The wave properties or characteristics of electrons
Yes, sir.
helped in designing the device. Do you remember the device name? Helped
Yes.
in designing the device.
Yes, sir.
Can you name that?
Sir, designing the device.
Designing the device. What is the device? I want the name of it.
Electron microscope.
Yeah. Electron microscope.
Yes, sir.
Very important point.
Yes, sir.
Electron microscope, which has
Yes, sir.
very high resolution relative to compound microscope, optical microscope, you're right, which has very high resolution relative to the optical microscope.
Optical microscope.
Yeah. One can view the molecules. One can view molecules in a substance using it. One can view molecules, comma, study crystal structure using it with high resolution. Using it with high resolution.
Yes, sir.
Okay. Now, shall we do some problems, or I will give the problems and will you solve? What do you want me to do?
Sir, few problems we can solve.
Amma?
Few problems we can solve.
Okay, fine. You have to remember this relation. It's not a problem, in fact. It is a
Yes,
standard relation which you have to remember, right?
Yes, sir.
Take mark.
Yes, sir.
What is the momentum energy relation for a photon? What is the momentum energy relation
Momentum.
for a photon?
Momentum. Energy relation of a photon.
Yeah, do you remember that formula which I gave you yesterday? The mass of a material particle whose speeds are comparable to
M naught by
uh,
root, that's one.
m
Root
naught
over 1 plus
minus
1 minus b square by m square. C square.
p square by c square. Can you name the
Yes.
terms? M naught is
M naught is the mass of rest mass.
rest mass of particle. V is the
Yes, sir.
speed of the particle. C is the
Speed
speed
of
of light.
C is velocity of light.
Don't say velocity, speed. Okay. Then
Yes, sir.
you bring it to the numerator and m into, correct, root of
Yes, sir.
1 minus v square by c
Over
square is
1
equal to m naught. Correct?
is equals to M naught. Yes, sir.
Yes or no?
Yes, sir.
Now square it on both sides. M square
M square 1 minus B square by C square into M naught squares.
right. Then multiply on both sides with c to the power of 4. M square c to the power of 4 into 1 minus v square by c square is equal to m naught square c to the power of 4, correct?
Yes, sir.
I'm telling you, you need not remember this derivation.
Yes, sir.
You have to remember the final formula.
Yes, sir.
But I don't like to give the formula and ask you to mark up.
Yes, sir.
That's why I'm explaining the steps, okay?
Yes, sir.
Now expand this bracket.
M
Square to the power of 4 minus,
C square minus C square.
m square v square c square. Correct?
Yes, sir.
Correct or wrong?
Sir, correct, sir.
Good. Is equal to m square c to the power of 4. Correct?
Yes, sir.
Now, can I write as mc square whole square minus mv into c whole square is equal to m naught c square whole square.
Yes, sir.
Now, mc square, what is that? Energy.
Yes, sir.
M naught c square, rest energy. Correct?
Yes, sir. E naught.
E naught. mv means what?
Momentum.
Momentum. So mv into c, pc.
Yes, sir.
So what is the final equation? E square
E square minus PC is equals to E naught square.
Square, not MEC. MEC whole square is there, na?
Yes, sir.
Is
PC
equal
is
to
equal to, I mean,
E
P square
naught
is
square. Now take this P square, C square that side. So E square is equal to,
P square, C square plus E naught square, sir.
that's all. So what is E?
Is E naught square
Hmm.
plus P square, C square.
Correct? Yes or no?
Yes, sir.
Now, for a photon, you know, rest mass is 0.
Yes, sir.
Therefore, if rest mass is 0, what is E naught?
Rest mass is 0. E naught also 0, sir.
0. So what will you get for the formula for energy of photon?
For a photon, E is equals to root also will cancel, sir. PC, sir.
PC, simple.
Yes, sir.
Very important expressions, these two.
Yes, sir.
These two are very important equations.
Yes, sir.
You must remember, in general, for any material particle, the energy, rest energy, and momentum are related by the formula E is equal to root of E naught square plus P square C square.
Yes,
For
sir.
a photon,
Yes, sir.
rest mass is 0. Therefore,
Yes,
E naught becomes 0. Hence, if you substitute it, you will get energy of a photon will become P into C.
Yes, sir.
So, what is P? ME into C.
Yes, sir.
Correct?
Yes, sir.
Or H by ME into C.
Yes,
Due
sir.
to nature, de Broglie's formula.
E is equals to H by MV.
That's what I've been focusing since yesterday. Even last year also I've been telling, you must explore all possible relations from the basic concept.
Yes, sir.
That is nothing but technique of preparation to these competitive examinations. It's not no magic is there. It's not now difficulty is there. Only thing you should develop is you must have the logic. Start from the basic equation, keep on reducing as many number of relations as possible by applying various conditions. So in the
Yes,
last
sir.
also we applied a condition. What happens if it is a photon? We got E is equal to PC. Very important.
Yes, sir.
Now, based on this, one more question is there. You please take that also.
Yes, sir.
Have you copied, ma?
Yes, sir. Copy.
Understood?
Yes, sir.
A stream of photons are falling normally
Yes, sir.
on a photosensitive screen
Yes, sir.
in vacuum. Even formula important, very important formula. You must remember this. In vacuum and exerts a pressure P.
In a vacuum, exerts a pressure.
And exerts a pressure P.
Yes, sir.
If Divya, then net పనిచేస్తుందా లేదా? అసలు నాకు ఇది పెట్టమ్మా. చూడు yeah, could you hear me, ma?
Yes, sir.
Power has gone, so I connected with hotspot. Okay.
Yes, sir.
Yeah.
Yes, sir.
What I am giving you, what I was
Beam
telling,
of photon falling on the screen in a vacuum exerts a pressure P if.
exerts a pressure P, right?
Yes, sir.
Yeah, if I is the intensity, I is the intensity, or X you put. X is the intensity. Then relate,
Yes, sir.
momentum,
Yes, sir.
intensity. Then relate momentum and intensity.
Momentum.
And intensity.
Momentum and intensity. Yes, sir.
Now start with formula for pressure. Pressure P is equal to F by A. Correct?
M by A. Yes, sir.
F by A, force per unit area.
Yes, sir.
Thrust per unit area is nothing but pressure. This force is also called as thrust.
Yes, sir.
Thrust means capital T.
Yes, sir.
What is the difference between force and thrust? Which force is called thrust? Can you tell me? They should have done it in properties of matter.
Yes, sir.
Yeah, which force you will call it as thrust? Will all the forces become thrust?
No, sir.
No. Say, this is the surface on which the light radiation is falling. That's what he is telling. This is normal to the surface,
Yes, sir.
and this is the radiation falling on the surface. So the angle is theta. The force exerted by this radiation when it is falling at some angle theta with the normal is simply called as force.
Yes, sir.
Now, if it strikes the surface normally, then this force is called as thrust.
Yes, sir.
So thrust is nothing but force only.
Yes, sir.
The normal component of force on a surface is called thrust.
Thrust.
Okay, ma?
Yes, sir.
So
Yes, sir.
here, according to the Newton's second law, the force is nothing but, yes, I'll use J for momentum,
Yes, sir.
or for pressure we'll say, we'll change the symbol. Pressure, what symbol shall we keep?
Yes.
I'll write in terms.
Yes, sir.
So F is equal to,
Yes, sir.
rate of change of momentum, correct?
Yes, sir.
Delta P by delta T. So
Yes,
substitute
sir.
in the formula for pressure. Yeah, delta P delta T multiplied by A. Correct?
Yes, sir.
And we got E is equal to PC. Correct?
Yes, sir.
So delta E will be equal to delta P into C.
Yes, sir.
So can you tell me what is delta P?
Delta P is momentum, sir.
Change in momentum.
Change in momentum, sir.
So from this relation, E is equal to, earlier problem we got now, E is equal to PC for photon.
Yes, sir. Delta P is change in momentum, sir.
Delta P is delta E by C.
Yes, sir.
So, now substitute in this.
E
It is
by E.
delta E by
Pressure is equals to
delta T into
delta P by delta E into delta T into A, sir.
Tell me once again, I could not hear you properly.
Sir, pressure is equals to
Hmm.
delta E by C into delta T into A, sir.
Okay. Now, do you remember the formula for intensity, ma? Intensity, I or X? Okay, you want I?
No problem, sir.
Shall we put X only?
Yes, sir.
Okay. Intensity is given by, intensity of any radiation is given by
Energy.
total amount of energy falling on a surface per unit area per unit time.
Yes, sir.
So what is this delta E? Can you tell me what is this?
This is only intensity, sir.
Yes. So finally, what are you getting? Pressure P
Pressure pressure is equals to
X by C. Correct? Huh?
IOX by C, sir.
So pressure of any photon radiation, pressure of any electromagnetic radiation striking the surface will be
Yes.
given by intensity by speed of light.
Yes, sir.
You have, do you have photo cells on your house?
Yes, sir.
Photovoltaic cells you have on your house, eh?
Yes, sir.
So what happens? Light from the sun, light and heat radiation from the sun will be striking that photovoltaic cells.
Then the electrons will get emitted, sir.
Yeah, that goes to battery and the battery get charged and you will get power.
Yes, sir.
So here this X stands for the intensity of light radiation striking those solar cells.
Yes, sir.
And C stands for speed of light.
Yes, sir. Yes, sir.
Then the pressure P is given by X by C. Intensity by speed.
Yes, sir.
Now, have you ever physically felt
Yes,
the intensity of solar radiations?
no, sir.
Have you understood my question?
Yes, sir. No, sir. I cannot. Yes, sir.
The intensity of solar radiations.
Yes, sir.
How you experienced and how it will be. Yeah. How will be the intensity of heat radiations? How you experienced it? Suppose you are standing in shade, right?
Yes, sir.
At 12 o'clock, at 12 noon, you went outside under the sun.
Yes, sir.
At 12 o'clock, you know, the heat radiations from the sun will be striking your hand normally, right? Suppose this is your hand, the solar radiations will be striking your hand normally like this
Yes, sir.
at 12 noon.
Yes, sir.
So the intensity is maximum.
Yes, sir.
So what is your feeling? You feel some chit like this feeling, will you get or not?
Yes, sir.
And as a result of it, melanin formation and skin gets black.
Yes, sir.
Yeah. So physically you can feel the pressure due to light radiations and heat radiations whenever you stand under a sun or whenever you go near a flame, etc.
Yeah. Yes, sir.
So today I'm concluding the class here.
Yes, sir.
Tomorrow we'll do some problems based on this concept
Yes, sir.
and go to photoelectric effect. Very important concept from NEET perspective. Okay?
Yes, sir. Yes, sir.
You're comfortable now?
Yes, sir. Comfortable.
Are you able to understand?
Yes, sir.
Any problem? If suppose you don't understand any concept today, tomorrow morning
Yes,
before we begin the topic, you have to clarify.
Yes, sir.
Okay?
Yes, sir.
Right, ma. All the best. Keep working. Daily you need to work 2 to 3 hours on what I'm doing today.
Yes, sir.
Yeah, knowledge book you can work out. Wonderful book. Whatever topics I am doing, just
Yes, sir.
don't do anything other than this.
Yes, sir.
Because I promise I'll complete everything by maximum August 15th.
Yes, sir.
Both 12th and 11th classes.
Yes, sir.
So just follow my schedule.
Yes, sir.
Daily make it a point to read NCERT textbook, make all the important concepts, then do some selected models of questions and problems.
Yes, sir.
Select standard models, do them more number of times. Don't do 100 or 150 things present in the book. No, that's
Yes,
waste.
sir. Yes,
Select 15, 20 questions and do more number of times.
yes, sir.
Okay, ma. Take care.
Yes, sir.
Bye-bye.
Yes, sir. Yes, sir. Thank you. Yes, sir. Thank you.
Okay, ma.